Welcome to another video by Adeptis Academy. Have you ever heard of an inductor? If not, you're not alone. Inductors are tiny, often overlooked, but absolutely essential in electronics. Most people have never seen one up close, and even fewer know what they do. But once you understand their role, you'll see just how important they are. An inductor is a small electrical component, sometimes no bigger than a grain of rice or a button, but don't let its size fool you. Inductors look like tightly wound coils of copper wire. This coil shape is the secret to how they work. Imagine a slinky toy made of copper wire. The spiral shape gives the inductor its special properties. Inductors come in all sizes, from tiny ones in earbuds to massive coils in power stations. They help manage electricity, store energy, and filter out unwanted signals in our devices. Their main job is to store energy in a magnetic field when electricity passes through and release it when needed. Think of them as traffic controllers for electricity, making sure everything flows smoothly and safely. Inductors are found in almost every electronic device, from smartphones and computers to cars and TVs. Though we rarely see them, we benefit from inductors every day. They help make our devices faster, safer, and more reliable. So next time you use your phone or watch TV, remember the humble inductor. It may be small, but it truly has a big job, helping to power the modern world, one tiny coil at a time. We might not see them, but inductors are everywhere in our daily lives. They are tucked away inside many common devices, quietly doing their job. For instance, have you ever used a wireless charger for your phone? Inside that charger, an inductor helps transfer energy wirelessly to your phone's battery. Pretty cool, right? Inductors are also key components in power supplies. Those bulky adapters that power our laptops and other electronics, they use inductors to smooth out the electricity flow, ensuring our devices get a steady supply of power. Without inductors, our electronics would be prone to damage from unstable electricity. Ever wondered how radios tune into specific stations? You guessed it, inductors are involved. They help select the desired radio frequency, filtering out all the other stations. This allows us to enjoy our favorite music and programs without interference. From AM radios to sophisticated communication systems, inductors play a vital role in transmitting and receiving information wirelessly. These are just a few examples of where we find inductors working diligently behind the scenes. Their ability to control and manipulate electricity makes them essential for a vast array of electronic applications. As technology advances, we can expect to see even more innovative uses for these tiny but mighty components. Inductors might seem mysterious, but their operation is rooted in electromagnetism, the same principle behind electric motors, transformers, and even your headphones. Inductors are everywhere, quietly working in countless electronic devices. So what is electromagnetism? Simply put, electricity and magnetism are deeply connected. When electricity flows through a wire, it creates a magnetic field around it. You can see this in action. Place a compass near a current-carrying wire, and the needle moves, responding to the invisible magnetic field. And a changing magnetic field can also create electricity. This is electromagnetic induction, the principle behind generators. An inductor is simply a coil of wire, often wrapped around a core. Coiling the wire concentrates the magnetic field, making the inductor more effective. When electricity flows through the coil, it generates a magnetic field. The more loops, the stronger the field. This magnetic field resists sudden changes in current. If you try to quickly increase or decrease the current, the inductor pushes back, trying to keep things steady. Think of it like a water hose. When you turn it on, there's a brief delay before the flow is steady. Similarly, an inductor resists sudden changes in current. If you suddenly stop the current, the magnetic field collapses, releasing its stored energy as a brief surge, sometimes even causing a visible spark. This unique ability to resist changes in current and release energy makes inductors essential in electronics, from power supplies to radio circuits. So next time you spot a tiny coil on a circuit board, remember, it's harnessing the magic of electromagnetism to keep your electronics running smoothly. Did you know that inductors can store energy just like tiny batteries? It might sound surprising, but these small, coiled components found on circuit boards are more than just passive parts. They play an active role in managing energy within electronic devices. It's true. Inductors have a special relationship with magnetism that allows them to temporarily hold on to energy. This unique property is what makes them so valuable in the world of electronics. We learned earlier that when electricity flows through an inductor, it creates a magnetic field around the coil. This magnetic field is invisible, but it's very real and powerful. This magnetic field actually stores energy within it, like a compressed spring ready to release. The tighter the coil and the stronger the current, the more energy can be stored in that magnetic field. Think of it like stretching a rubber band. The more you stretch it, the more energy you store in the band. When you stretch the rubber band, you store energy in it. That energy is just waiting to be released. Let go, and the rubber band snaps back, releasing the stored energy. The process is quick and dramatic, just like what happens inside an inductor when the current changes. Similarly, when electricity flows through an inductor, it stretches the magnetic field, storing energy. The inductor resists changes in the current, almost as if it's trying to keep things steady by holding on to that energy. When the electrical current is interrupted or reduced, the magnetic field collapses, releasing the stored energy back into the circuit. This release can happen in an instant, sending a surge of energy through the wires. This process is fundamental to how inductors work. They don't just passively sit in a circuit, they actively manage the flow of energy, absorbing it when there's too much and releasing it when there's too little. This stored energy isn't permanent like in a battery. Unlike a battery, which can hold energy for hours or even days, an inductor only stores energy as long as the magnetic field exists. It's temporary and released quickly when the current changes. The energy is there one moment and gone the next, making inductors perfect for applications that need rapid bursts of power. However, this ability to store and release energy rapidly makes inductors incredibly useful in many electronic circuits. They're essential for smoothing out electrical signals, filtering noise, and even protecting sensitive components from sudden surges. In power supplies, for example, inductors help convert fluctuating voltages into steady, usable power. They act as shock absorbers, evening out the bumps in the flow of electricity. For example, inductors are used in camera flashes to store energy and release it in a sudden burst, creating the bright flash of light. Without inductors, that quick, intense burst of energy wouldn't be possible. They're also used in some types of energy-efficient lighting, where they help regulate the flow of electricity to the bulb, reducing energy waste. This makes lighting systems more reliable and cost-effective. Inductors are even at the heart of wireless charging technology. They create and receive magnetic fields that transfer energy from a charging pad to your device. No wires needed. The ability of inductors to act like tiny energy reservoirs is a key reason why they are indispensable in modern electronics. From smoothing out power to enabling wireless charging, these small components play a huge role in making our technology work smoothly and efficiently. Thank you for watching this episode and for taking the time to learn more about electronics. See you in the next video.